This video is about rate of change. Problem 1. The diagram shows that an 8-foot ladder AB is leaning against a wall. The distance from the bottom of the ladder to the wall BC equals x, and the height from the top of the ladder to the ground AC equals y. The angle ABC equals theta. Write down the value of the variables. Y, theta, the area A at the instant when the bottom of a ladder is 4 feet from the wall. We know this is a right triangle. For this right triangle, we can use the Pythagorean theorem to figure out this y. Y squared plus 4 squared equals 8 squared. So y equals 64 minus 16 equals 48. So square root 48. Simplify 4 square root of 3. For this theta, we will use SOHCAHTOA. This is adjacent. This is a hypotenuse. So we will use cosine theta equals 4 over 8. That is 1 over 2. So theta equals arc cosine 1 over 2 equals pi over 3. For the area equals 1/2 of base times height. 1/2 base is 4. Height is y. We already figured out 4 square root of 3. That equals 8 square root of 3. Question 2. Fill out the table below. Given that the bottom of the ladder is sliding along the floor at the rate of 2 feet per second. Variables x and y. Relationship between the variables. According to this right triangle, we know x squared plus y squared equals 8 squared. That is 64. Relationship between rate of change in general. We know x is the function of t. Y is the function of t. We will take a derivative with respect to t for this equation, which means for x squared, we will get 2x times dx by dt. And y squared, that is 2y times dy by dt. So we get 2x times dx by dt plus 2y times dy by dt. 64 is a constant. Derivative of constant is 0. Relationship between rate of change at the instant when x equals 4. When x equals 4, we already figured out y equals 4 square root of 3. We will get 2 times 4 times dx by dt. According to this information, we know dx by dt equals 2 feet per second times 2 plus 2 times 4 square root of 3 times dy by dt equals 0. 16 plus 8 square root of 3 dy by dt equals 0. Minus 16 both sides, then divided by 8 square root of 3 dy by dt equals negative 16 over 8 square root of 3. That is a negative 2 square root of 3 over 3 dy by dt x equals 4 equals negative 2 square root of 3 over 3. For variables x and theta, we know theta is also a function of t. X and theta, we will use cosine theta equals x over 8. Take a derivative with respect to t. Negative sine theta d theta by dt equals 1 over 8 dx by dt. When x equals 4, we know theta equals pi over 3. Let's do the substitution. Negative sine pi over 3 d theta by dt equals 1 over 8 times 2. Sine pi over 3 is a negative square root of 3 over 2 d theta by dt equals reduce 1 over 4. Then multiply by 2 both sides. Negative square root of 3 d theta by dt equals 1 over 2. Then divided by negative square root of 3 both sides. D theta by dt equals negative square root of 3 over 6 d theta by dt equals negative square root of 3 over 6. Variable area x and y. Area equals 1/2 x times y. We know the area is also a function of t. So we will take a derivative with respect to t for this equation. dA by dt equals, for this 1/2 for xy, we need to do product rule. 1/2 times dx by dt times y plus 1/2 x times dy by dt. Do not forget to do product rule for xy because we are taking derivative with respect to t. X and y are both functions of t. So we get 1/2 for y dx by dt plus 1/2 x dy by dt. Since we already figured out dy by dt equals negative 2 square root of 3 over 3. Let's do the substitution. dA by dt equals 1/2. Y is 4 square root of 3 times 2 plus 1/2 times 4 dy by dt is negative 2 square root of 3 over 3. Simplify. 4 square root of 3 plus negative 4 square root of 3 over 3. Make a same denominator, multiply by 3, multiply by 3. So we get 12 square root of 3 minus 4 square root of 3. Final answer will be 8 square root of 3 over 3. We can write down the answer dA by dt as x equals 4 equals 8 square root of 3 over 3.